So those are the two main ideas what we have. So yesterday, when we looked at things, we could find the results on here, or we could determine them that way. So today we're going to be looking at not using this, but instead using our calculator. So you'll have to be able to shift back and forth from radians to degrees on your calculator. Okay, so my button has a DRG button that shifts from radians, which is RAD, and degrees, which is DEG on them. These kinds of calculators have that. So you'll be shifting back and forth from radians to degrees. And that's one of the big errors that happens in this area, is people forget to shift their calculator, and then they'll get a result that's a little bit different. So make sure that you're familiar with the calculator and how to shift from degrees to radians. If you're not sure, you can ask me and I'll help you out. Okay, so the first thing we're going to do is just simple finding approximate values. The simpler one, the easier one. Let me pull up my example. So first thing we're going to do is finding approximate values. Okay, so this will be where you're given a trigonometric ratio and you have to find the approximate value to either 4 or 3 decimal places, depending on what they ask. We'll do 3 decimal places in our example. So it'll be stuff like this. Determine the value of each to 3 decimal places. Okay, so we'll just start out with the easiest one of all. Just if we had something like sine of 20 degrees, which I got to put a degree symbol on mine. I don't have a degree symbol on this thing, so I'll just use them. Okay, that's just use your calculator. Now, if there's a degree symbol, that means it's in degrees, so we use that. So you just go on your calculator, sine 20, 0.342. Pretty easy to do. Okay, easy enough. Okay, the other one that you might show up here is you might get a reciprocal identity. So and that's where you have to use reciprocal identities, which are not on your calculator. So you have to use the relationship. So maybe I'll just use the marker because then I can write degrees down. So what are those relationships? Well, cosecant, or so let's start with cotan. Cotan is 1 over tan. Okay, if you're trying to convert tan into cotan, you use that. Cosecant, okay, that's 1 over sine. And secant, that's 1 over cosine. Okay, now on your calculator you always have tan, sine, and cosine, but you don't have cotan, cosecant, and secant, so you just convert it by plugging in the value you get from your calculator on the bottom. So for example, if I had B, I wanted you to find, let's say, cosecant of 20. Okay. Okay, and we know that we've already got the sine of 20. We already know that that's 1 over the sine of 20. So this would just be equal to 1 over 0.342. Take your calculator out and divide that out, and you get 2.924. Okay, so that's how you find approximate values. Now, You can plug it in there. It's on your calculator for 3 of the functions. For the reciprocal functions, these are the relationships that you would use. You just flip them over, basically. Okay, so that's the easy part, using the calculator, finding the decimal number, the value of a sine, a cosine, a tangent, or a cosecant, a secant, or a cotangent. The more difficult part is, what if you're given the value of the cosecant or the sine, and you have to find out what the angle is? Okay, that's where we use inverse tan, inverse sine, inverse cosine, and we have to look at the whole picture in quadrants. So that's the more difficult one. So, and we are going to be using reference angles. So that's the easy part. So we're going to change to blue and do the harder part. So this is converting from a ratio to an angle. Okay, and this requires a couple of steps at least. Okay, so what we'll do is we'll do an example, and we'll do an easy example first. We'll do, let's say, what is the angle okay, and we'll do a degree one, let's say for, let's say it's cosine theta equals negative 0.285. Okay, that's what we're going to do. So the first thing is, major key, never, ever, ever use the negative sign in your inverse cosine. Never. The negative sign tells you what quadrants this is located in. So let's just do one from 0 to 360. Okay, so we'll do one rotation of the circle. Okay, so we know that, so we don't ignore the ignore. So let's spell, oops. Ignore the negative sign when finding the reference angle. So don't use that negative sign. Always assume that it's positive, because that'll give you the reference angle that you're going to use. So that's the first thing we're going to do. Find the reference angle, which we'll call theta r, which stands for the reference angle. Okay, so take your calculator out, go inverse cosine of 0.285 without the negative. And that's going to equal our reference angle. That's not going to give us our angle, that's going to give us our reference angle for each quadrant that's negative. Okay, so take your calculator, get this thing, okay, make sure it's in degrees. So mine's in DEG, as you can see on the top there. Okay, and then you go inverse. Now, if you have a forward calculator or a backward calculator, mine's forward. You go second function, cosine, get that inverse on it like that, and then put decimal 285 equal sign. Okay, it's 73.4 degrees, so we'll round it off to just 73 degrees so we don't have to worry about decimals for now. So our reference angle is 73 degrees. Okay, now what we're going to do is we're going to draw our quadrants, because we're going once around the circle. And we're going to see where is cosine negative. And we're going to draw our two references in. So step 2 is to, let me move this out of the way here. Okay, step 2 is to sketch the quadrants or the circle. We'll just say the quads. Okay, so here I'm going to sketch it. So I'm going to put my quad here. Now, where is cosine negative? So we're going to go cast rule. Where is cosine negative? Cosine is positive here and here. So cosine is negative in this quadrant and cosine is negative in this quadrant. Right? So cosine is positive in the fourth quadrant because that's what the C stands for, right? Cosine is positive in the first quadrant. That's what the A stands for. So this means all. This means cosine. This means sine. And this means tan. So now we know that our reference angle is going to be here. And I'll draw these with an arrow. And let's use this limey green here. Whoop. Try that again. Okay, so the slimy green. So there's going to be where my angle is in the, I'm going to make a 73-degree angle. Remember the 73-degree angle is always with the x-axis. And I'm going to make another 73-degree angle here. So this, and I label it up. Okay, my reference angle here is 73 degrees and 73 degrees. Because it's negative right there and saying, so what is this angle? And what is that angle? Actually, you know what? Let's do those ones in a different color for the actual angles. So let's do the actual angles in red. Okay, so the actual angle number 1 is measured here, and the actual angle number 2 is measured there. So step 3, find the two angles, the standard angles. Now, is it going to be always two angles? No. It might be, depending on what they might ask you to do 2 rounds. They might ask you to do half a round. They might ask you to do whatever different kinds of rounds, right? I usually ask 1 round in my examples. So so this is 73. What's this little angle left then? Well, this is 90 degrees. So this little angle left would be 90 minus 73, which would be 17. So this is 90 plus 17. So theta would equal 90 plus 17. That's 107. And the second one, okay, we got, this is 90 here. This is 180 here. So it's just 180 plus 73. 180 plus 73. So that's 153. Okay, so now you're going to check. Take your calculator, go cosine 107. You should get decimal 0.285 negative. I get 0.292 because we rounded off to 73. So that's close, right? And if I go cos 153, or sorry, 250, pardon me, this is 200, right? Because 180 plus 73. 280, 252. And I get negative 0.92, which is close. Because I rounded off a little bit, if we would have used decimal, you know, if we would have used our actual 73.4, we probably would have been right on. So we're good. So there's the 3 steps of finding an example of finding that angle given an approximate value. Okay. Step 1, put it into your calculator and get a reference angle, ignoring the negative. Step 2, draw the quadrants and use the negative sign or the positive sign to see where the terminal angles or the reference angles are. Draw the 2 reference angles, figure them out. Okay, so that's using degrees. Okay, and that's using a cosine. Now, you can also have one that uses radians, and you can also have one that uses a reciprocal identity. So we'll do one example of each of those as well today. Okay, any questions on that? It's pretty straightforward. Okay, so let's do one with radians. Okay, next. Okay, I'm going to flip the page here. Okay, so this is the same kind of example. We'll do example 2 here. Okay, and this time we're going to do different range too, a different. Okay, so let's say we have sine. Last time I used cosine. Let's use sine of equals sine theta equals. I better figure out what a good radian is here. All right, so let's say sine is negative 0.7568. And let's say that this is going to go from 0 to, okay, sometimes they just write 0, 2, or sometimes they do this symbol to 2 pi. We'll go 1 round. Okay, I'll stick with 1 round. Okay, now that because you see this, you know that it's in radians. So the first thing you do here is change your calculator to radians. Okay, and then you're going to ignore the negative. And then we're going to go inverse sine of the 0.7. Okay, and this is going to give us our reference angle in radians. Now it's going to give us to it in pi. No, it'll just be a number. So take a calculator, or try it out. Go inverse sine of 0.7568. Okay, and I get 0.858 radians. But remember that 90 degrees is about 1.57 radians. So that's about, it's probably like a 50-degree angle. 858. Everybody get that? Okay, remember we're working in radians. This is where people often make mistakes. Keep it in radians. Okay, now we're going to draw our picture. Okay, cast. Okay, where is sine negative? Sine is negative sine is positive there, and sine is positive there. So sine is negative here and here. So we've got to draw a reference angle in the second and third, or sorry, in the third and fourth quadrants. There's positive there, positive there. Sine's positive, sine's positive. So we're going to draw it here. So I'll just use a green line. Draw the quad there. This is 0.858 radians. Okay, and then draw the quad one right there. This is 0.858 radians. So there's our two reference angles. Okay, now because we're using radians, we got to go, okay, how do I figure this out? Well, remember, this is 0. This is pi over 2. Okay, so if you do pi over 2, that's 1.57 radians. If you're on your calculator, you can just go hit your pi button, which let's see if I've got one here. There it is, and divide by 2. 1.571, basically. Okay, and then this is pi, which is 3.14, and this is 3 pi over 2. Which is, if we do 3 pi divided by 2, that's 4.71. And this one over here is 2 pi, which equals 6.28. So that's how you can figure out your angles. So now that you've got that figured out, we can say that this angle here, which we'll do in blue, our first standard angle, we go all the way around. So we're going to take 3.14 and add 0.858. And that's going to give us our first measurement in radians. So 3.14 plus 0.858. So I get 3.998. So we'll say 4. Okay, and then this one here, we're going to go 6.28 radians, and we're going to subtract 0.858. Okay, and I get 5.42 will go radians. Okay, and that's one round. So therefore my answer is theta equals 4 and 5.42 radians. Okay. Okay, let's double check. You can go take your calculator, go sine of, make sure it's in radians, sine of 4. Okay, I get negative 0.7568. Oh, right on, perfect. Okay, let's clear that off and go sine of 5.242. Negative 0.7599. So it's a little bit off, but not a bunch off, because we rounded that one a little bit. Okay, so good. Okay, so those are two examples, and the third and final informational thing we want to do, or example we want to do, is what about if you have a value where you're dealing with secant, cosecant, or cotan? Okay, how do you deal with that? Okay, so we'll do an example like that. So when you're dealing with that, you have to do conversions, because the calculator has sine, cosine, and tangent on it. And you want to be able to use this in sine, cosine, and tangent. So we'll maybe go back to degrees, and we'll do our final type of example here. Let me just double check to make sure. Okay, domain-wise, I'm going to also change the domain to not just be one round this time, because they've got a couple of them in here where they ask for you to do one where it's not just one round. So we'll also do that as well. But this will be our final one. Any questions on that one? Okay, no different than the first one, just changing from degrees to radians. Okay, our final example today is, let's do an example where we're using a reciprocal identity. So, okay, and we'll use degrees again. So let's say that we're going to do, let's do secant theta equals I'm just going to let's say that secant theta equals 1.10. Okay, so that's positive. And we're going to say we want theta is in between let's say we want it from negative 180 degrees to positive 180 degrees. Okay, so we're going to go, basically I'm saying the same thing as one round, right? But I want you to give the answer in negatives over on this side and positives on this side. Okay? So it just depends on how they list, how they want the answers. Okay, so let's change. So the first thing we've got to do is we've got to change the secant into a cosine. So we do this first. So this is the one extra step that you got to do when you have a reciprocal identity. First thing you do is change it to a primary. So step one, we're going to change that to a primary. Okay, so that just means you're going to divide. Cosine theta equals 1 divided by 1.100. Okay, do that on the calculator. 1 divided by 1.1.
Are we in degrees?
Yeah, we're in degrees, yeah. That's what this is here. Yeah. So make sure that your degrees, you're in your degrees on here as well. Because that will give you a wonky result if you still are in radians. And also there's gradulins on your calculators. So 1 divided by 1.1, I get 0.9090. So we'll go 0.9091 if we round it up. Okay, and then now what we're going to do is we're going to do inverse cosine. So step 2 is cosine inverse. Okay, and that's going to give us our reference angle. So check your calculator, make sure it's in degrees. If you've done the divide, just leave that whole thing right on your calculator and just go second function cosine equal. So I get 24.6. Okay, so 25 degrees if we're going to go to the nearest degree. Or we could use decimal if we want, but we'll go to the nearest one. So this is 25 degrees. Okay, now we have to draw our domain that we have. Okay, so from 0 to positive 180, that's this way, and 0 to negative 180, that's this way, right? So where is cosine positive? Well, it'd be right here. And right here. Okay, so this is 25 degrees. And this is 25 degrees. Because Castro. Okay, now we got to state our answers like this. We're going to go once down. We're going to go down from here to here. That's going to answer this part. And then we're going to go from here to here. So this is pretty easy. So theta equals 25 degrees for the positive part. And for the negative part, it equals what? Negative 25 degrees. Like that. Pretty easy. That one's easy. Okay, so when it asks you to do a negative one like this, you start from here and you go around this way, right? If it asks you to do positive, start from here and go. Now, if I said from 0 to 360, you'd have to go around twice, right? So this tells you how to state your answers and whether it's in radians or degrees, usually. And that's basically the types of questions they'll have. Now, they might have a question like, tell whether it's positive or negative, what quadrant it'd be in or something. And it'll say cosine 40 degrees. And you say, well, that's positive. Or it'll say sine 190. And you'd be like, oh, that's negative because that's in the third quadrant. Stuff like that. They'll ask questions like that as well. Okay, so that's it for today's instructional part of our math. Any questions on those types of examples? So that gets us all the way to 4.3. Okay, so I'll give you your practice area. Let me just look through if there's anything different here. Nope. Okay, so second part of chapter 4 deals with a little bit more. So practice. This is on page 201 and again and 202. Okay. And for practice on this, okay, this basically using your calculator for number 2 there. Okay, don't do the whole thing, just do like A, C, E, G, so column 1. Okay, and then in that one it says give the approximate value. Okay, so that you're just using your calculator. Okay, if you have a pi button on your calculator. Now remember, when there's no degree sign, it means radians. So you'll be changing your calculator from degrees to radians. Okay, and then skip 3 and do 4. Okay, and if you look at 4, it's just asking you to express each of the given angles using the same trigonometric ratio as a reference angle. So they're just telling you what are the reference angles. Okay, so just converting it into reference angles. Okay, and skip 5 and do 6. Okay, 6 is indicate whether it's a positive or negative, so you can do them all there. Okay, 7 is determine each value. Okay, so that's kind of what we were doing for examples. And then 8 is, it's kind of a blend of yesterday and today. Okay, you might get a little stuck on that one, but if you do, you can ask me tomorrow. That's kind of a blend of yesterday and today. Calculating your y value first and then figuring out what the value of tan and cosecant is. And then finally, 10. Let's do A and C. Okay, and that's it for today. Okay, any questions that you have? I'll stay online for a bit. That went for about 37 minutes or so. So you got about 20 minutes, a little over 20 minutes to work on stuff. Okay, and then tomorrow we're into solving equations. So 4.4 will probably take us, I'm guessing, 1 or 2 periods. So we're pretty much almost through the first chapter 4 stuff. It's about halfway through the first unit. All right.